Good afternoon. Today we're going to learn Norton equivalent circuit. Basically, with a Norton equivalent circuit, you have a current source in parallel with R Norton, in parallel with the load. This is the load. So we want to get the current through the Norton area or the Norton load. The first thing we do is we short Nort. So we short that. It also wants to see voltage drops in the circuit instead of current. So right here, we have to do a source conversion. 0.5 milliamps times 15K gives you a voltage of 7.5 volts. And remember, when we do a source conversion, current in parallel is voltage in series. So when we redraw this of 23 volts, we have 2K, we have 3K, got the 2.5, and now we have 15K, and since the current was going up, the voltage shall go up. 7.5 volts, and right here is our Norton. So we want to get the current at this area right here. So what I see is just a regular series parallel circuit. We can use mesh analysis on this. So we can say I1, we get the current here, and then I2 to get the current there. And then obviously I2 will be the I Norton. So that's much helpful. So we're going to do it in format approach. So plus something I1 minus something I2 equals something. Then it's negative something I1 plus something I2 equals something. So with the format approach, when you're using mesh, make sure that you write the format. So this first one, what's the first thing we see? Okay, well, what are the components that are in I1 current? Well, it's 2 plus 3K, so it's 5K ohms. For here, what is the component touching I1 plus I2? That would be 3K. Since the current is flowing this way, we're entering the negative side of the battery. So on the other side of the equation, it would be a positive 23 volts. Okay? Then we work on I2 equation. What is the component between I1 and I2? That would be the 3K. What are all the resistors touching I1? Now, even if you put this 1.5K ohm here for your Norton equivalent, you do not count it because it's shorted. Remember, every time you short a circuit, then you cannot, the current will always travel the path of least resistance. So we have to count all the other ones. So it's 20.5K ohms. What's the voltage? We're entering positive 7.5, so on this side of the equation it would be negative 7.5 volts. So then we put this, now this I'm going to show you on the calculator. We're going to make sure that we use the menu. We're going to go down to equation. We're going to use simultaneous equations, F1. There's only two unknowns. And so this is the matrix, we just kind of put it in. So this is plus 5K ohms, negative 3K, 23 volts. The next one is negative 3K, plus 20.5K, and negative 7.5 volts. And now we just hit solve. And so for I1, here, this current, we have 4.80 So I1 equals 4.80 milliamps, and then I2, go here, come down, we actually have 0.337 milliamps. Because this is an exponent -4, we either have to go 1 to the left to make it milli, or we could have made it 2 to the right to make it micro. So this can also be 339 microamps. Okay? So now that we know that I2 is 339 microamps, okay, we put that in our circuit. So it's going this way, so it'd be negative, so it's going down, and it would be 339 microamps is the I Norton. To get R Norton, remember we do the same thing like we do Thevenin. We short this and we short the batteries and open the currents. And then your Norton would be here. You're going to look back. So in this case, if your battery was here and you shorted these two, you have to work on this side. Okay? So we have to get 2K in parallel with 3K. Go ahead and get that. You should have gotten 1.2 K ohms. So 1.2 K ohms, right, is here. So this takes place of these two together. Then that's here, so then you have 2.5 K, and then you have 15 K. And then this is your look back method, right? So what do you see is just a regular series circuit. So you have 15K plus 1.2K plus 2.5K ohms, and you have a total of 18.7K ohms. So that's your Norton equivalent, 18.7K. So that's R Norton. This is your I Norton, and then you put back the load. We'll talk about how to get the voltage for this the next circuit. Okay, bye.